So in this video we look at RGB LEDs, and I've got one of these LEDs here. So this is an RGB LED. It has 4 legs, and I've also got a red, blue and a green LED. So we look how we can build this up ourselves. And let's quickly have a look how these things look in more detail. And I'm sort of taking the other camera and let's go a bit closer here. So what we see here, those are the 3 regular LEDs. And what you can see, they have the legs that are of different lengths. So we remember plus is the longer leg, minus the shorter. So if we now look at this LED, we see it has 4 legs. One is the longest, and the other ones, there are 2 shorter ones on one side and 1 shorter on the other one. And yeah, let's check what this is. So coming back to this data sheet, and I've got taken here a data sheet for an RGB, so full color LED it's called. It has these 3 colors built into one. And so essentially, and we see this here in the schematic, it is really just 3 LEDs parallel. The important part is what we see here, pin 2, that's the longest, that's in this case minus. So the longest pin in contrast here is minus, that goes to ground. And it's important here that we put the resistors on each of the LEDs. And why is this important? Because if we have one LED on and we assume we go with 20 milliamps, 20 milliamps goes through here. If we have 2 LEDs on, so there go 20 in here, 20 in here, then there are 40 coming out. And if we do 3 LEDs parallel and each of them has a current of 20 milliamps, we can add it up, we have 60 milliamps. And so the current that goes through the resistor is different. That's why it's important to have the resistor at each of the LEDs. Not one resistor for all 3, each of the LEDs has one resistor. So this is really important to keep in mind. And now let's have a quick look, and I draw what we have. So let's switch. I have a bit more space on the table. So what we really have is we have 3 LEDs that are in parallel. So I draw 3 LEDs. This is one. Then we have another one. And there is a third one. So we have the 3 LEDs. Now, what we call is common ground. So this is our pin 2. All 3 of them will go to the same pin. So we can draw this, and we could do this with normal LEDs as well. So all the minus go together, and we connect this side to ground. And now what do we do on the other side? We need a resistor for each of the LEDs. So we have 1 resistor for this LED, and we have 1 resistor for this LED, and we have 1 resistor for this LED. And let's just go with the 100 ohm, which we used before. And we see it's not optimal, but I show you in a minute why. And what do we do? For each of them, we need plus here, so we can use a pin to drive it here. So let's think in a moment which pins we are going to use to drive that. But first, let me build up the same thing with just using regular LEDs. So we remember the long side is plus, so basically the LED is this way round. And so I build them up here. So this is the plus side, so I put 1 into this one, and I create sort of, I put 1 into 10 with the plus leg and 15 with the minus leg. So then I put the second in. The plus leg I put also in 15. And I put also the minus leg in 15. And this one I put the plus leg into 20, doesn't matter where, and the minus leg also into 15. We have to make sure that we can really have them in there. So what we have now, I have 3 LEDs next to each other, and it's basically really what we have here. And I show you with the close-up camera. So what you see here, and I'll switch it over. What you see here is the 3 LEDs next to each other. And what we do here, you can see on the one side of the 15, and I show this is on this side, all 3 are connected. This is our minus side. This is what we have here. And then we have the other side where we don't have the resistor yet. So I put the resistors in. So let me quickly do that. So I take the 100 ohm resistors and I take 3 of them. And so let's just put them into one direction. So I say I put the first one, I put 10 to 20. So let's go here. I put the blue LED, I put into 22. The green LED I put into 24, and usually I leave one in between. That makes it less likely that I by accident connect it into the, and I put the red one into 26. Okay, so we have a look again with the close-up. So now let's have a look at a close-up. So if we look here, what we can see is I connect one leg of the LED with the resistor, and that's very much what we see here. So for the blue one, and then so I have now the LED can be the red LED. I can plug something in here, go through the resistor, through the LED, and to ground here. So now let's connect this one to ground of our microcontroller, because that's where we get. So I use here this pin. That's where all the grounds are, and here I have the ground at the first one. So the other thing I can do now, I just connect my microcontroller, and a bit blurry here, but let's get it connected first and then we bother about this. So I have now connected the microcontroller, and so far from the microcontroller, the only thing we use is really the ground. Now what can I do? I can just use another cable. Let's have a look here for a bit longer cable. Just a sec. So what we do here, I have already connected the black cable to ground, and now I just take the 3.3 volts. And now let's see if I'm not using the microcontroller as a microcontroller. At the moment, I'm just using it as a source for power. So if I connect this here, we see the red one is on. If I connect it here, we see the green one is on. And if I connect it here, we can see the blue one is on. So I have 3 LEDs. And now what I do, here I connect really sort of the power, like sort of 3.3 volts. So this is like putting power here. But what is more interesting is now connecting it really to the chip. And I switch back to the other view. So what we do now is I look which of the pins can I use to do that. And just let's have a look here. So I have the pin out diagram here. And so last time we used pin 26 for an external LED. So let's just use pin 26, pin 27, and pin 14. So I have 3 cables here. I take out this one. So let's have another look, and I can switch again, that's a bit easier to see. So we do pin 26, that's where the yellow goes, and I connect the red one to this one. I have pin 27 here, and I can connect this to this LED, and I can connect the last pin to this one. So you see one of them is on, the others are off. So let's have a quick look how we can program that. So let's get back, and what do we need? We need our development environment, and I have it here. And now I can start writing some code. And if we remember, we can quickly have a look how to, and I search here, micropython.org. We go to the documents, and here we have the reference for ESP32. And what we are interested in the first is the pins. And if you remember, we can do this one, and I just get this code that we get started. So let's first connect to COM4. That's what we have, and now let's create a new file. And so we import from machine pin, and from time we import sleep. And now let's say we create, we have pin 14, which is this one, which is connected to blue. So I call it blue is pin 14, and it's an output. And I just copy this one, and this is 14. And then we have, when we look, we have just look here. So we use 14, 27, and 26. So the next one is pin 27, which is connected to green. And then we use 26, which is connected to red. And now what we do is we do a loop while true, and what do? We say blue on, green on, red on. We sleep for 1 second, and then we switch all of them off, and I just copy them, and we just change on to off. And I delete this part. So now we have to save this under a name. And I save it to the workspace as RGB01. And now we can just put it onto the chip. Let's try this, and let's see what happens. What do we see? All 3 LEDs are lighting up. And this is sort of the first step. So now can we stop it here? We did a keyboard interrupt, so we can now blink all 3 LEDs. Now the question is, can we replace these LEDs with a single LED? Let's have a quicker look again. So let's have a look what we have. So I open again the datasheet, which we had here. So this datasheet says the common ground is 2. That's the longer one. So I get over here, and then I have sort of 1 and the other. So what I do is I just replace the 1 LED here, or replace the LEDs I have in the board with this 1 LED. So let me do that. So I put the 1 LED, the 1 leg in here. Then let's get started with this one that goes in the middle. This one leg goes here. There's one more leg that goes in here. Hopefully the connections are made. So let's have a look again if we run the program, if it works. And what we see, it's blinking, and in this case it's white. So let's do it a bit differently. Let's change our code to, basically we switch all of them off first. Let's do that. So I should switch all of them off. Let it sleep for 1 second. Then I switch the blue one on, the green one, and the red one. The colors may not be right anymore. Why is this? Because I really didn't look if I had them in the right, in the same order. So let's stop it here and try again. So red, green, blue. Red, green, blue. So they should be all three on at the end, and basically so we add them up. So the first one is red, and then we add red and green together, and then blue. So let's try if this is really like this. So we switch just the one off, which we blue dot off, and then we have green on, and then green dot off and red on, and then we can still do one where we have all of them on. I just copy this. And we sleep for another second at the end. So let's run this again. We stop it and let's run it again. So what happens? We have red on, we have green on, we have blue on, and all of them on. So and I go now also again with the other camera where we have a bit closer sort of. Let me switch this over. I have lost this camera, but now it's back again. And let's do that. So what we see now is we have the LED in different lights. So we switch red, green, blue, and then all colors, which gives us white. Red, green, blue, and it's pretty hard to see with the colors on the camera, but yeah, if I see it correctly, it's nice. So let's see what happens if I go closer. It is just too bright that we have it. So red, green, blue, you get an idea of it, and white for it. Okay, so let's go back. And now there is one more thing we have to look at. It's how can we mix the color? And this is something where we would like to have a function where we switch them selectively. And so one of the things we can do here is we can use the Pulpit Modulation. So I do a new program where I just do it with one pin. So we need PWM, which is Pulpit Modulation. So let's have a quick look how we can do this. So I copy this over. So what we need to also include PWM. And I delete this loop at the moment. So what we do is now we put, for example, our blue, and I'm not sure which color this is, so probably I should check. So let's quickly do blue on and see which one this is. This seems to be red. Now let's do red on. Now I have to switch them off before I do all of them. So let's do that. So red is blue, so we have to change this one. So let's say this is 14, and then we swap this over to 26. Let's try. So let's try again. Okay, so red is red. So now let's do blue on. Blue works, and let's do green on. Okay, so we have now again the right colors because I just earlier switched that back. So again, we lost another camera. We have got it back, so we have green on. And now what we can do is we say green, and I think I've copied it over. So we have already included the pulse width modulation. And now what can we do? We say the pin, which we had as pin out, we use them as PWM. So we say here PWM, pulse width modulation, and we just say pin 26, and we don't need the rest. So now we have this, and we can do this for the others as well. So we get all of them as pulse width modulation. And now we can get rid of this. And so what we do, we can now set the frequency or get the frequency. So what we do is we set for all of them the frequency to 1 kilohertz. And this is just setting it to 1000. So this is our pulse width. And I do this for all three. Okay, so we have the, and now what we can see, we can now set the duty cycle, which is a number between 0 and 1023. And 0 means it's off, 1023 means it's on all the time. I just draw this here, then we can have a quick look. So what I can do now is for the pulse width modulation, so what we do is we send out a signal that looks like this. And this is one period. And the signal repeats here. And what we say, this is sort of, this duration is 1024. And we just say, how much is this part? That's basically what we write into duty. So in this case, let's say that is 400 and this is 624. So this would be 40 to 60 roughly on off. And this is basically what we can do with pulse width modulation. So with the duty, we just say how long it's on. And now let's try this for, let's try with blue. So blue duty is, let's do 200. And let's switch this on. And so we see the others are on. So let's switch sort of to different one. Let's do it like this. Let's do the blue to 0. Let's do green to 0, and let's do red to 1000. So now basically what we should see is a red LED lighting up. And how does this work? We create 3 signals, and I showed it here again. So in this case, we create a signal for blue, and we create a signal for green, and we create a signal for red. And what we basically have, the blue signal is at 0, the green signal is at 0, and the red signal is most of the time at 1, and it only goes down very quickly, and then it's again. So now what can we do? We can create something else where we say it should be, the blue should be on to 50%. This would be something like this. And we want to have green on also 50%, but we want to have red off. Let's do that. So we can now mix the colors. And so basically what we do here is we say, okay, green 50% is 500. Blue, green, and this one goes to 0. And now let's see what happens. So it's mainly blue. Should we reduce the blue a little bit? So we go with the blue to 300 and with the green to 800. So it should move a bit closer to green. And you can see the color is really pretty bad on the camera, but you can really see. And so usually we have something, if we talk about RGB colors, we have something like RGB, and then we say 255, 255, 255. And this is something where we would get white. And for us, this would look like that we have to put blue to 1000, green to 1000, and red to 1000, or 1024. So we can take a shortcut. We just basically, let's define this function. Def RGB, and we say red, green, blue. And wait, I have to. Okay, and then we say, and I can just copy them down. And so we just say, because here we have the values from 0 to 255, and here we need the ones from 2024. So we just say, this is blue times 4. This is green times 4. And this one is red times 4. And now we can basically have and I just copy this up, this function. After the frequencies, here we are. And now what I can do, I can now say RGB. And so, as I said, 255, 255, 255, that should be white. And if I do the same thing with zeros, it should be black. In our case, this is off. And if I do, let's take this one, and I have to put a sleep in between. And if I do here a 1, that should be red. If I, no, 255, sorry, 255, 255, this should be green. And this should be blue. And I just put a loop around because that's nicer. So let's see if this works. Save it and we run it. Red, green, blue. And so we can see we can now mix colors, and this function which we have here gives us sort of access to any color we want to produce. And I hope with this piece of code you can run the RGB LED and you have understood how it's built up. I think it's important there are also RGB LEDs that speak a protocol. They are intelligent, so-called intelligent RGB LED. It's the same as the NeoPixel, and you just use a library for doing that. So let's stop this one here and try it out.